Hey everyone, I'm Richard. I'm the co-founder of Nap.ai, and I just wanted to create a video about Model Context Protocol, which a lot of people are talking about at the moment. I was at the AI Engineering Summit in New York, and there was a really great workshop by Anthropic on Model Context Protocol. It was basically this room of, 100 different engineers asking this guy from Anthropic questions. And, it was the first time that the penny really dropped for me with MCP. I had a bunch of questions that I hadn't managed to get answered yet. And this was just, 100 engineers asking all of the questions that we had. And a lot of the questions that people asked were, the same ones that I was wondering about. So I hope to go through some of those questions and the answers in this talk. I also highly recommend checking out the workshop itself. I'll put links to all of these in the description below. But I think you can watch the full thing here. Swix also does a really good summary of some of the different slides that are in the presentation. So I recommend checking out these. So first of all, why does MCP exist? The basic architecture is that you have this MCP client, which could be something like Anthropic Desktop or Cursor or some other desktop app, and you want to use that client with which usually has an LLM. So that's the other part of the system, is this LLM that mostly works with closed models. So Anthropic wants you to use Anthropic Cloud. Of course, that doesn't run in the same place as the client. So that's another node. And then you have this third one, which is the MCP server, which is usually for some sort of tool that you want to use to add context into your prompt of your LLM. So let's use Slack as an example. Maybe Slack store your data on the cloud. Maybe we want to use that data when we're running our Anthropic desktop locally. So Slack will set up an MCP server, which has an API, which the clients can then make calls to get data from Slack, and then put that data into the context of the LLM, which just means that the LLM should be able to generate better responses because it has more context about, for example, your message history or something like that. So that's kind of the idea behind MCP and why it exists. There's some nice pictures here. They even there's even some slides that talk about using it for memory, which is like a little bit different to tools. I don't think this is fully supported yet. Also Anthropic announced that they're going to launch an MCP registry at some point in the next couple of weeks. And there's even like a decentralized component, which I like. So yeah, recommend checking out this this tweet along with the video just to get like full context on the Anthropic workshop that happened. What I'm going to do is dive in a little bit into the code of the MCP servers, where the different repos are. There's also a really nice framework called MCP Agent that was mentioned in the talk, which is about how to build agents using some of the MCP servers that I'm going to dive in. And I'm also going to touch on similar things that NAPTA does and how we're planning to fully support MCP in the next couple of weeks. Okay, so first of all, there's this repo called servers on the Model Context Protocol organization. It basically has a full list of all of the different servers, or at least most of the servers that that you can use MCP with. There's also some like really simple ones to get you started. The weather one is the one that they show in the Model Context Protocol docs. I recommend checking that out. But if you look at it, it's basically just a Python package, right? Or they also have TypeScript version, so it's like it can be an npm package as well. For the Python packages, they always use UV, which is kind of like poetry but faster. This is the layout of a very simple MCP server. You just have like the package files themselves, the toml file, as well as the lock file. You have a README. Then you have some sort of main Python file, which imports the MCP Python SDK, instantiates the MCP server, and then you add these like decorators for tools that you want to add to the tool registry. So yeah, this is a very simple MCP server, the most basic example that they show you in the docs. There's also, some more elaborate ones. So the weather one that I showed you doesn't actually spin up a server when you launch it. There's two different types of MCP servers. There's ones that use standard IO, standard input output. So that's like one type which doesn't actually spin up a server as far as I can see. And then you also have SSE, which is like when you're actually using a remote server. So there's this example called Simple Tool, which you can run in either mode. You can run it in either standard input output mode or in SSE mode. if you run it in SSE mode, it actually spins up a Python server using Starless and then launches the server. So if you don't use SSE, if we go back to the weather example, there's actually no servers here. It basically just runs the package locally, as far as I can see at least. So that's an example of a remote server using Starless. Again, this package has a very similar format. It has like a TOML file, a README, and a directory with some sort of like main file. They have this really nice example called create Python server. It's just it's the basic structure of an MCP server that you need. They also have some Jinja files to like, create the README even and that sort of thing. So when you run MCP create server, it'll actually like generate the README and stuff for you as well. But yeah, I guess you can just clone this repo, run a command, and it will create like the basic structure of an MCP server for you, which is really nice. I just wanted to take a quick look at NAPTA modules and just show how they're similar to MCP servers. So we have these things called modules, which are basically just Python packages. We use Poetry, but are planning to update it to use UV instead of Poetry. But this is like, it has a very similar structure to an MCP server. This is for like a tool that just generates an image using the stability API, for example. We have a lock file, a TOML file, a README. There's some extra stuff in here, like an environment for, secret variables and that sort of thing. And then we have like a main file, which we always call run.py, which is where it actually runs. So this is like analogous to weather.py in the weather example. So, the tool modules in NAPTA are very similar. We also have this thing called a module template, which is very similar to the create Python server. Basically, you just need to clone this and it gives you the basic structure of a module. And then you can just, change stuff in the like run.py file. I actually really like the idea of using the Jinja templates to create a new module, because whenever you fork a module, you always have the same README, and it would be nice to kind of like auto generate a README, so you don't have this like boilerplate every time. So I've definitely gotten a few ideas from the Anthropic Python create server. So yeah, that's NAPTA modules and how they're similar to MCP servers. I wrote this tweet just the other day, just to say that, we're going to start supporting MCP. So we've done something like MCP for quite a while, like 6 to 12 months. For 6 to 12 months, you've been able to use run an agent locally, for example, on your laptop. And for that agent to make a call to another node, that runs a tool module. So agent running on your laptop, tool module running on a different, server or device. And that agent is still able to use the context provided by that tool. So we've been doing that for quite a long time. But, we're not fully MCP compatible. We do something similar, and we want to tap into the, growing community in MCP. So we're planning to adopt it fully. Okay, so the other thing that I wanted to mention from the talk was this really interesting slide that that was showed. And Mahesh talked about how he wants MCP to move more towards this like multi-agent use case that's shown in the slide. So the example that he gives is this orchestrator agent, which is running both an MCP server and an MCP client, orchestrating these other 3 agents, and each agent is running an MCP server and an MCP client. And all of these agents are cooperating together using MCP. So he talked about this as a direction that he wants MCP to go. Now, as I mentioned, NAPTA has been able to support something like agents calling tools for quite a while. We've also supported, agents making calls to other agents, or orchestrators making calls to other agents for quite a while too. You can see that in this image from our docs, for example. So we can have like an orchestrator module running on one node, and that orchestrator module can make calls to an agent running on a different node, and that agent can then make a call to a tool module running on a different node. So all of these different modules can run on different devices. So we can basically already support something like the MCP use case. It's just that we're not fully MCP compatible yet. But as I mentioned, that's a minor change. And so, once we make that in the next week or two, we should be able to, out of the box support use cases that are quite similar to this demo that was shown in the talk. Okay, so yeah, and what other modules are available in the NAPTA stack? So we don't just have agents, tools, and orchestrators. We also have other things like environment modules, knowledge-based modules, and memory modules. So if you remember in one of the other slides that Swick showed in his tweet, he talked about making a call to not a tool module, but a memory module. That's also something that the NAPTA stack supports already. And another thing that would be really nice that I haven't heard, that someone's got working in the MCP community is making a call to a remote knowledge base, which is like slightly different to a tool. I guess you could have a knowledge base that has an API, for example, but wouldn't it be nice if you could actually have like a database where you store knowledge as well? And, the agent running on your laptop could interact with this remote knowledge base, or that could even be like a shared knowledge base, which is shared by a lot of people that are running, agents on their laptops, for example. Agents could contribute to this shared knowledge base. So these are all things that are supported by NAPTA already. And we will do that. We'll be able to do that soon in an MCP compatible format. The other type of module that we have is like environment. This is more like a reinforcement learning environment. And it just means that, maybe you could have agents that take part in, some shared environment, which could be like Minecraft, or it could be, doesn't even need to be graphical. It could just be some sort of text-based environment. And for all of those agents to get rewards based on that environment to do some sort of like multi-agent reinforcement learning. So these are all use cases that we can already do on NAPTA, and, we'll be able to do in an MCP compatible way in the next week or two. So I mentioned MCP agent as another really cool framework. This was brought up during the talk as well. And what Mahesh said was that he really liked this example of like agents using, MCP servers. So you can see here how it's called. You have this agent class, and then in the agent class, you basically specify a list of the different MCP servers, and then this agent can make calls to those servers. So when I saw this, I wondered if MCP agent have, worked towards the multi-agent use case that was mentioned in the slides by having an agent as itself an MCP server. So I went to the Discord of Last Mile AI and I asked, and yeah, they've already been working on this example of an MCP agent as a server. So I can put this in the description below, a link to this, but this is basically a server built using the MCP agent framework that itself can act as an MCP server, and it uses like these tool decorators currently. So yeah, this is a really cool example as well. There's some other nice examples of agents in the MCP agent framework. So this is what an MCP agent looks like. It has a requirements.txt file. It has a config.yaml file, which is where you like specify the schema for the agent, for example. You specify the different MCP servers, some other stuff like which LLM to use. There's also like a secrets place for all of your API keys. And then there's like a main file of the agent itself, which imports the agent class from the MCP agent framework, and then, has some sort of like way of running it. So that's a really nice example. That's for like a researcher. There's a ton of other examples here. There's even one for like a swarm as well, which is really cool. This is kind of like the orchestrator in the NAPTA framework, right? They have this main file. They import this like Anthropic swarm class, and then they have this class for like swarm agents as well. So this is a really cool example of a swarm, which is starting to work towards this like multi-agent use case that was talked about in the slides. Okay, so just to show what agent modules look like in the NAPTA framework, we currently have agent modules as basically identical to tool modules. So they all have the same package format. We have the simple chat agent. It's basically a poetry package. It has the same TOML file, the same lock file, exact same structure. It has like a run.py file where the main code is. And we have something similar to the configs that we showed before. So if you remember in the MCP agent, there were configs for like, the LLM and stuff. We have this like LLM configs file, for example, where you can store multiple LLMs that you want to use your agent with. So OpenAI or like Olama or whatever. And we also have this like config for the agent itself, where you can define, the system prompt and like what persona you want that agent to use, which LLM you want it to use, even like which device you want it to run on, etc. So the agent module is actually very similar to the MCP agent that comes from the MCP agent framework. I'm actually chatting to the guy behind the MCP agent framework, and one of the things that I said would be cool to like figure out is whether we should use the same format for MCP server tools as we do for MCP server agents. I think that would be a nice thing to have, and that's something that we're going to discuss. Yeah, and also NAPTA has these like orchestrator modules. So I showed the like swarm that in the MCP agent framework. We also have something similar in NAPTA. Instead of just a single agent, it's a for example multi agent. And again, these orchestrator modules have the exact same format as the agent modules and the tool modules. And it's the same for knowledge base modules, environment modules. They all just look like poetry packages. So yeah, there's a bunch of really cool stuff going on in the MCP ecosystem. We really want to tap into it. And the way that we want to do that is by, first of all, making ourselves compatible with MCP. And that's going to take like 1 to 2 weeks. As I mentioned, there's a few small differences. Like we use poetry, they use UV. There's a few things that we need to figure out and get working, but it's like very minimal changes. And we already do something very, very similar to MCP. And there's a request for comments doc in the NAPTA community now that talks about the small changes that need to be made. It compares the structure of the MCP servers and the NAPTA modules. It talks about a bunch of other stuff, like how can we support these like multi-agent use cases. It looks at MCP agent. It talks about the format for, these agents that are MCP compatible and what they should be. It talks about how to instantiate these agents through the agent class. It talks about swarms. So I'll leave a link to this in the description below. Would love to get people's comments in the community. And yeah, I think that we can do something really cool here. First of all, by extending all of the cool demos that the MCP community has created to further support this like multi-agent use case, support knowledge bases running on different nodes, memory. All of this stuff is like really, really exciting, and I can't wait to demo some of these things in a fully MCP compatible way. So yeah, hope you enjoyed the video. If you have any questions about MCP or some thoughts on like how to move forward with extending it, if you have any thoughts about NAPTA modules or any questions, please feel free to reach out. And yeah, looking forward to discussing how to bring MCP even further.